All right. Thank you, everybody, for joining. And this is our first session for the Python Basic Study Group. We're part of the Cognitive Science Discord server. So, in our server, we study anything related to the mind, to artificial intelligence, brain sciences, philosophy of mind, psychology. We have a reading group held on Sundays for psychoanalysis. We're currently reading Freud. Please let me know and ping me in the chat if you're interested in that as well. But as part of exploring artificial intelligence and machine learning, we decided to form a study group just to go over, AI and the basics of programming. So for beginners, I thought the best place to start would really be an introduction to Python. So in this group, we're going over the book Automate the Boring Stuff with Python. It's a great book. It's what I started out with. It's available free online, and if you have no experience programming, or maybe that you're not really strong in your mathematical background, that's no worry. It's very approachable, and it's really will cover the solid foundations you need to go on to the more advanced studies, whether they're in machine learning or object-oriented programming. It's a great place to start. So, because I know a lot of the people who signed up for the meetup are completely new to programming, some people are in high school, I just thought I'd give like a total beginner's overview of what programming is, what Python is, and being a history buff myself and really loving to know the story behind something, I really wanted to introduce the topic by giving a little background into the history of computer science. So we could ask, when did computer science begin, and when was the first computer made? I would argue it began around 2400 BC with the invention of the abacus, which some could see as really the first tool, dedicated device made for doing computations, which was really simple arithmetic. We have a picture right here. And it really wasn't until the 17th century that we had something that resembled more of a computer that we have today, or something we might recognize as being a computer. So Pascal, famous philosopher and theologian, you might have heard before of Pascal's wager, which was an argument for why we should believe in God. And that's a tangent, but I'd love to talk about it sometime with you if you're interested in that subject as well. But he was a polymath, and he had invented this essentially a calculator right here. It's very elaborate. It's very beautiful looking, actually. But essentially, what it was it was the first mechanical calculator. We skip ahead to the 19th century, and what we see is Charles Babbage's analytical engine, which he never completed it in his lifetime, but what this was meant to be was essentially a steam-powered general-purpose computation device. So this was something that could do advanced mathematics, it could do logic problems. They had various use cases for this device, but as I said before, it was not completed during his lifetime. Very large, elaborate-looking machine, but theoretically was capable of doing a lot. Babbage, he had a friend named Ada Lovelace, and she really should be considered the first programmer. And she designed, even though the hardware was not finished during their lifetime, she had come up with algorithms for computations the analytical engine could perform. And you could see that right here, some of her work. And what this is actually a Bernoulli equation, and how that would be implemented on the analytical engine. Now, in the 20th century, we see the birth of modern computing. Alan Turing, not only did his contributions help to win World War II through his work on the Enigma machine, but he also laid the theoretical foundations for computer science as we know it today. Around 1945, we see the ENIAC, which was the first general-purpose computer, and John von Neumann came up with the architecture of the modern computer, which is why we call it von Neumann architecture. You may have heard of this before. Soon after, we see the first modern programming languages: assembly, Fortran, COBOL. And the next question to ask, if we don't already know, is really what are computer languages? And computer languages are the way we give instructions to a computer. Ultimately, instructions boil down to zeros and ones, which can be thought of as the presence or absence of an electrical charge on a given computer's circuits. Now, of course, if you want to build a massive application like ChatGPT or a video game like World of Warcraft, you aren't going to be able to sit down and write that in terms of zeros and ones. So what programming languages, high-level programming languages let us do is they let us abstract away the details of the underlying hardware and infrastructure and give us a convenient way to give instructions and data to a computer. Now, Python. Everybody's talking about Python. Everybody wants to learn Python. Python was developed in 1991, and at first, it was really used mostly in academia. And a lot of hardcore programmers have some quips with Python, and a lot of them are valid. But what's great about Python is not only are there a lot of support and libraries available for anyone who wants to learn, but it has a very simple and intuitive syntax, which makes it a great programming language to start out with if you just want to learn the concepts of computer programming. You can build just about anything you want in Python. You can make video games, you can do artificial intelligence and machine learning, you can do automation, you can even make websites with libraries like Flask, which are able to generate HTML, CSS, and JavaScript that can run in a web browser. So let's go ahead, let's write our first computer program. I'm sure you've heard of it before, the Hello World. So this is everybody's first program, and all it is a simple print statement that will print to the console, and what we put is hello world. We run that. You can run that in your Jupyter notebook just by pressing this run cell, and we get the text. You could see that on a command line as well, or a CMD. We can get a little more interesting. We can have these variables, we can print out their contents as well with the print function. So if I want to print the variable my age, go ahead and print that out as well. So now our output changed from anything you'd like, the string we saw before, to this integer. Now, variables. In Python, variables are essentially addresses to a location in memory. So what this does is we take this variable, it could be X or Y or anything we name it that conforms to Python's naming conventions for variables, and we can reference a value stored in memory. What are some of the data types? What's the data we can work with when we're working with the Python programming language? Well, some of the most fundamental and basic data types are the numerical data types, including integers and floats, which are numbers with decimal points like 1.110, etc. We can work with raw text, like a string, like we have right here. My name is Lee, that's a string. You can see it's wrapped in quotes. It doesn't need to be a single word or name. It could be an entire sentence. And we can also work with Boolean values like true and false, and you'll learn a little bit more about those later. Those are also very important. So let's see some of this in action. We'll run this cell. We had the value age, height, name is student, and that's our Boolean. So now, instead of hard coding the output we want in an entire string and then calling the print statement on that, we can have our data stored in these variables. And then, for example, if we had a more complex set of functions here, we might not know what age or height needs to be, but we could pull those values or calculate those values, store them in a variable, and then reference them when we finally want to see the output. So now what we have is, I want to print age, I get age 25, we get height, name, and is student true. Now, operators in Python are what allow us to perform operations on our variables. So you can see for each of the fundamental data types, we have a special set of operators that we can use with them. So for arithmetic, you have everything you would expect, multiplication, division, modulus. For comparison operators, we have greater than, less than, is equal to, is not equal to, and we'll see those in action later. And for the logical operators like true and false, Boolean values, we have and, or, and not. So here we can see some arithmetic in action. We have A equals 10, B equals 3, and we can see, for example, A plus B equals 13, as we'd expect. And for more advanced operations, we can import the Python math library. So we can see right here the exponential, A to the third power in this case. So we get 1,000. And for square root, we have that as well. Operations on strings. Operations on strings allow us to do anything you'd want to do with a piece of text. So, for example, we have this string hello world, just the original string. We can print out its value, or we could say, I want to make it all uppercase. Hello world. All we have to do is run this function dot upper on the original string, and it converts it to uppercase. We can convert it to all lowercase. We can get the length of the string, so that's the number of characters in the string. That's going to include the white space as well, so be careful about that. We could say I only want to see the first 5 characters of a string, so we can see right here that's hello, or we can say we can go backwards and count the last 6 characters, which gives us world, exclamation point. If we want to join strings, for example, right here, we have a greeting, hello, and we have a name, Alice. So I want to see hello, Alice. Right here, all we have to do is we can use this plus sign. So instead of adding numerical values, we're concatenating, which is combining these string values. So right here, we can see the output, hello Alice. And right here, if we want to form the name Batman, we could take this string, Batman, add them together and get Batman. I am Batman. We want to make sure that we leave the bat in there as well, because otherwise we're just going to get I am man. Nobody wants that. So up to this point, we've been running functions. We were using print. We were using functions like upper and lower. But let's say, for example, we want to create our own. Well, Python lets us do that. So functions, as you would expect, just like in math, they allow us to perform operations on our input. And given any input, we can get the desired output. So if we want to define a function, for example, we want to create a function that says hello given any name we give it. All we have to do is define, give the name of our function, give the inputs that we want to provide to it, and then we tell our function what we want to do with that data. So in this case, in our greet function, we want to return the combined string hello and whatever name we pass to it. So here, we run this code, we say, I want to greet Alice and I want to greet Bob. And we get the desired result. Hello Alice, hello Bob. Now we're going to move on to the subject of control flow. And we're going to start with conditional logic. And what control flow really is it's us telling the program how we want it to behave given the values it has for its variables. So for example, I want to write a program that can tell someone if they're eligible to vote or not. And what we say is, given an age, if that age is greater than 18, tell them they're eligible to vote. Otherwise, they're not eligible yet. They'll have to wait till they're 18 at least. So in our example, we give the age of 20, and we want to know if someone who is 20 years old is eligible to vote. We'll run this code, and indeed they are. Now, writing conditional logic in Python can seem a little intimidating at first, but you'll find out in a while that it's a very intuitive concept, and it's something you do in your everyday life without even thinking about it really. So, for example, let's say if you want to know if it's safe to go outside or not. Is it raining? Well, first you would ask yourself, is it raining? You look out the window. If it's not raining, you'd simply go outside, no issue. However, if it is raining, the next question you need to ask yourself is, do you have an umbrella? If you do, go right outside, just grab your umbrella. However, if you don't have an umbrella and it is raining, you need to wait a while. You need to wait and continually look outside after some time to see if it's still raining. If it's still raining, you wait a little longer. You look outside the window, and until it stops raining, is it raining? No, you won't be able to go outside. But once it does stop, you're good. And then we can end this program. So what does that look like in Python? Well, first we'll have our two variables. Is it raining? And have umbrella. So right here in this example, we have is raining set to true and have umbrella set to false. But I want to change this first. So let's say is raining is false. So what does our program do if raining is false? We ask if is raining. So if is raining is true, we'll start executing the lines indented underneath this if statement. However, we see up here that is raining is set to false. So instead of this if clause, what we activate is under this else clause. So we say if is raining is true, it's not, we go to else. And what does it say? Go outside. Now let's change it up. Let's say is raining is true. However, we do have an umbrella. Our program runs and it asks, is raining true? It is. So we'll activate the next line. We'll set this new variable called still raining to true. Then we ask if have umbrella. If have umbrella is true, we go outside. Now, what happens in this instance? We have is raining is true and have umbrella is true. So we ask, if is raining is true, it is. So we go to the next line, we set the variable still raining to true. Then we ask, if have umbrella. Have umbrella is true, so we'll activate this clause. Let's see it run. Go outside, you have an umbrella. Now, we'll set have umbrella to false. So it's raining outside and we don't have an umbrella. So we'll run. What happens? Have umbrella is false, so we go to this else clause. Then we activate a while loop. And what this really says is, while this string or this value is true, we start activating these lines. So what does it ask? It asks for some user input, which is what this function gathers. And it asks, is it still raining? Yes or no. If it is still raining, we're told to stay indoors a little longer. And then we go back up to this while loop from the beginning. But if we put no, it's no longer raining, then we set still raining to false, and we print it stopped raining, go outside. We'll go back up to while still raining. We'll see that still raining is false, and then we'll break out of this loop. So is it still raining? Yes, it's still raining. Stay indoors a little longer. Now, it asks us again. I look outside, it's no longer raining, and I say no, it's no longer raining. It stopped raining, go outside. and our program is complete. Now, before we leave for the day, I want to go ahead and introduce you to two fundamental data structures in Python, and those are lists and dictionaries. Lists allow us to refer to a group of objects with a single variable. They're an ordered, changeable list of items. So, for example, we can have a list of numbers. We have this list right here. It's called numbers, is its name. And we set it equal to, you see these open and closed brackets. Those indicate a list. And what we have in it is the first item is 1, 2, all the way up to 5. For our second list, we have string values. It's called fruits. And what we set it equal to is this list right here, which contains the strings apple, banana, and cherry. We can even have a mixed list. So for example, mixed is equal to a list containing 1, the number, hello, the string, 3.5, the float, and true, which is a Boolean value. We print those out. We can see numbers. When we print that out, it gives us the list 1, 2, 3, 4, 5, fruits, and mixed. Now, when we want to refer to a single item in a list, we have to refer to it by its index. How indexes work in Python are we count from 0. So for example, 1 is at index 0, 2 is at index 1. It's a little strange at first, but you'll get used to it. So we'll run this. We see, so how we count is the first index starts from 0, then index 1, then index 2, 3, 4, and that's the last element in the list. In Python, we also have ways to iterate backwards through a list. So for example, if we just want a convenient way to refer to the last item, but we don't know how long the list is, we can grab that by counting backwards. We'll count -1, and that should give us the value cherry. If we want to just get the 2 first fruits, how we can do that is we start at the index we want, and then we end at the index we don't want. So we start at index 0, index 1. This is at index 2. 2 is not included. This is like the boundary point. So running this, we'll get the first 2 items. We'll get index 1, index 0, index 1, and then we'll stop at 2. So we'll run this, and just as we expect, we got indices up to 2. So we got index 0 and index 1. And when we count backwards, we get the last item. We got cherry, which is the last item in our list. Some common list functions include getting the length of a list. So we have 4 items right here. We should get 4. It allows us to sort a given list in terms of the values within that list, and allows us to reverse it. We can even find the maximum and minimum values within a list. So you can see the output right here, and we have a length of 4, a max of 8, and a minimum of 1. Dictionaries in Python are just like real dictionaries. So for example, if you wanted to look up the meaning of a word, you would simply look for a word, and that would give you the definition. In a Python dictionary, you provide a certain key, and once you call for that key, it returns a value. So for example, if I want to know the definition of the word cat, what I'll do is I'll call my simple dictionary and provide the key value cat. We'll run this, and what we find is when we call simple dictionary with the key cat, it provides us with the definition: a small animal that says meow. For book, we provide that key, and it yields the corresponding value: a set of pages with words or pictures. If we want to add a new value to our dictionary, so a new key like tree, we set it equal to its new value. So we have the key tree and the value a tall plant with a trunk and branches. We'll print that out. And we see we've updated our dictionary. So using dictionaries in Python, we can even make a little quiz game where the key is a question and the value is the answer to the question. So what we'll do in this program is we'll have a score, and we'll store that in a variable named score. We'll iterate, that is, move through the key value pairs in the dictionary, set them to question and answer, and say, for each question and answer in my questions dictionary, I want to provide the user with a certain question and have them input a response. We'll take that response and we'll say, if user answer equals answer from the dictionary, that is the value, we'll set their score equal to +1. Otherwise, we'll tell them they're incorrect. And at the end of the for loop, we'll print out their final score. So we'll go ahead and run this. We have the first key value pair, and it asks us, what is the capital of France? Paris. I hit enter. Correct. Now it wants to know what's 2 + 2, 4, and who wrote Hamlet? That is Shakespeare. And our score is 3 out of 3. Thanks again for joining.